we'll start with the house and what we did to it to make it more efficient, more comfortable, and just more livable. And we'll progress from there to the things around the house. So this picture shows on the left is what the house looked like when we bought it, and on the right, what it looks like today. So you can see there's some few changes going on there, but they were really kind of consistent with the original design of the house. So you can see on the left, upper left there in 1937, the house had big roof overhangs, and there was an open porch on the southwest side there. And by 1958, you know, it looked quite a bit different. It had sidewall shingles, and the roof overhangs had been cut off, and that porch was enclosed. And when we got it, it kind of pretty much looked the same, except it had some aluminum windows instead. So we took that porch design and recreated it on the north side of the house and did a small addition to give us a little more space. And then we also turned the roof into a gable roof to make room for solar panels. So here's another view of the progress of that. And as you can see, it was over a number of years. But basically, most of the work took place in 2 to 3 years. It was really 2 years, and I think we finally painted it in 2005 or something. I don't know. Anyway, it's been a long project that we're still working on. The front stairs came off, and then we opened up the pony walls and discovered there wasn't a lot of framing down there. So those got reframed. On the left, you can see it was just some 6x6 posts and a bunch of random 2x4s. So we completely replaced that and tied it down with seismic anchors and insulated. That original insulation you can see on the left there, that yellow stuff, that was R7. So we actually kept that, but we added 2 layers of R13. And that was reclaimed insulation that we got at what was then Restore and is now Ballard Reuse. A really good resource for reclaimed building materials. So now we have R34 walls downstairs. Actually, I think there are R30 down here and R34 upstairs. The aluminum windows, we replaced those with actually reclaimed vinyl windows that we got at Second Use Building Materials. They were really a good find because they were a lot of the same size that we were able to use in our existing window openings. And they were low E, argon filled, dual glazed units, so pretty nice windows. The installation that we did was unusual in that we did the 2x4 walls with cellulose, but then on the inside, right over the old plaster and lath, we put R19 foil-faced foam insulation, and that really increased the value of the insulation value of the wall, but it also cut the thermal bridging at the studs and brought the corners in so that there's less heat leaking out at the corners. And in general, just made a huge difference. On the north side, where we did the addition, you can see on the left picture here, we put that same insulation over R21 bats. So the north wall, for the most part, is R40. Upstairs in the attic, we did R57 with about 2 feet of cellulose. So here's detail on that foam installation over the plaster and lath. We used 5-inch drywall screws to stitch all that in, and it worked great. The trim, we were able to, this house had no trim in it when we bought it. Somebody had taken all the trim out. So we recreated what we think, that 1908 window looked like. We were able to get period casing and some other parts like picture rail and cove molding. Most of that we got down at Restore. And we were kind of able to fake the other parts to put together the lintel and the sill and make it look like it was an old window. Here's some detail on the heating system. We have a complicated mechanical corner that includes the domestic hot water, including the solar input for that and the solar storage for that. And there, in addition to that, there's another water heating tank that is just for space heating. We reduced the heat load of the house by 2/3. So we were able to heat the entire house with just an electric water heater. And in 2013, we replaced that with a heat pump water heater, which cut the electric usage in half again. So really kind of remarkable progression with the heating load. Here's how we did the loops in the floor. Those are 1/2-inch PEX tubing that we just used conduit clips to clip up to the, or to screw up to the subfloor. The ceiling downstairs, we painted the back of the drywall flat black so it would absorb that radiation faster, because this system radiates both ways. And that's why there's so much tubing in each one of those joist cavities. Normally you'd only have maybe 2 tubes. But in this case, we have more heat flux where it's going up and down at the same time. This just, it's remarkably efficient and comfortable now. And you can see that infrared picture in the center showing the basement ceiling and the walls. The walls are purple and the ceiling is yellow because the ceiling is producing a lot of heat. And that actually radiates to the floor. So the floor warms up due to the fact that the radiant loops are in the ceiling. Pretty cool. In the bedroom, we did loops in the wall because we didn't want to heat that part of the basement below the bedroom. And in this case, we put those loops over some of that foil-faced insulation so we don't cook the dining room. And that actually reflects the heat back into the bedroom really well. So this thing heats up instantly, and you can't really tell where the heat's coming from, but it's very comfortable. We used a blower door to measure the leakage in the house. And the first time we did it, we were kind of surprised because there was a lot of leakage. And there were things that we just didn't think about when we did our remodel. So we went back and plugged up some of those places. And then we came back and did a blower door test again with a thermal camera and found leakage in places that we couldn't see. So for instance, there was a cold line along the basement wall where you could see the cold air was coming in behind that wall where the pony wall meets the foundation. So things like that. There was a blower door, a pocket door that was leaking air out of the pocket. And that's because it was coming in from a part of the ceiling that was open to the outside. So there were things we couldn't see that we found with that thermal camera. Amazing. And we got it to this point, which for this size house is right about where you want to have some mechanical ventilation. And actually our heat pump water heater provides that, oddly enough. But tightened up the house, you can see how much tighter we got it. This is a winter day, and the left is our house, and you can see the purple walls mean that there's not a lot of heat coming out of there. They're cold because they're just not receiving much from the inside. You can see the window frames and the glass is where the heat is really coming out of our house. Our next door neighbor's house, not so much. The walls and the windows, everything are radiating quite a bit more heat. So a good way to test to see how well we did our insulation work. Here's some other shots. This one upper left is another house in the neighborhood where you can really see that thing leaking. On the upper right, that's a picture of our dining room wall, and the dots are the screw heads, those 5-inch drywall screws I was telling you about, because that's the only thing that's really transferring heat through that wall. Plus in the corner where you typically get some leakage. And here's another detail of insulation we did downstairs. Air sealing with foam along the pony wall, and then we did vapor barrier. I think that was existing actually, and then we put 2-inch R14 polyiso board over that. Here's where the energy goes in our house. I love these Sankey diagrams because it really makes it visual. All the yellow arrows on the left there is solar coming from various resources. So we have the big PV system on the roof making 6,000 kilowatt hours a year. The small system on the garage actually produces about 700 to 800 a year. The patio roof in the 500 to 600 kilowatt hour range. Our hot water system makes about 1,800 kilowatt hours. That's based on the usage for a two-person household. And we get a lot of passive solar heating, and we've actually modeled that. Well, when we did the design work on the house, we used a program that models the heat loss and the solar gain. And we ran the model with all the windows shaded, and it took 25% more energy to heat the house. So we're getting about 25% of our space heating from the sun coming through the windows, and that's that passive heat figure there. So all of those yellow arrows really kind of neatly equal the red and purple and so forth on the other side where we're using that. And you can see those figures on the right. Those are all from the monitoring system we have, so we know where all that energy is going. And then down below, you've got the grid power coming in, but it's really only coming in to supply 2 electric cars. And hopefully someday we'll have enough production on the house to be able to make that up too. But this is something you can do at your house. There are all these things that we've been doing here. There's probably some of those you can do. So just want to encourage you to ask questions if you've got any.